Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and we are continuing our Advanced Algebra series today by looking at an advanced application of the difference of two squares, also known as the difference of perfect squares. So I'm assuming that you've watched our previous video on the difference of two squares. If you haven't, you're going to want to watch it first. This takes you through some more complex examples using those same principles. So that prerequisite knowledge is also that you have an understanding of index laws and surds, as we're going to be applying those as well in this video. Okay, so let's start with our first example of factorising x squared minus 10. Now, previously when we followed the pattern of difference of two squares, we looked at the first number and said to ourselves, is that a squared number? Yes, it is. And we would look at the second number and ask ourselves if it was a squared number and if there's a subtraction in between. And once we did that, we could apply the pattern of dots. However, in this particular example, you'll notice that I've got the number 10. It's not technically a squared number. So my first reaction there is, as a student, is to go, I can't do this question, put my hand up. Teacher, is there a mistake on this exam? Teacher comes over and says, no, there's not. And then you sit there and you move on and don't even attempt it because you have no idea what to do. Because you can't find a common factor between x squared and 10 and you've got no clue what's going on. However, applying what we know about surds, which you should have a bit of a knowledge about that, we'll be able to recognise that even though this is not a squared number, it is actually the square of a surd. So if I consider that the number 10 is equal to the square root of 10 multiplied by the square root of 10. Remember, when you multiply a surd by itself, the square root goes away because squaring undoes a square root. So the square root of 10 times the square root of 10 is simply 10. Let's try that with something else, with the number 100, for example. The square root of 100 is 10 and the square root of 100 is 10. So if I took the square root of 100 times the square root of 100, well, I'm going to be getting 10 times 10, which is 100. So squaring undoes squared roots. So even though this does not look like a squared number, technically it's the square of a surd. Okay, so every positive whole number can be expressed as a surd in some particular way. So this number 10 is technically the square of a surd. So our solution using dots, difference of two squares, is to recognise the square root of this is x. The square root of 10 is root 10, written in surd form. If you do it on your calculator, square root of 10, you're going to end up with a number with all sorts of irrational values. However, just leave it in surd form and then separate that using that dots process with a plus and a minus. Now, if you were to expand these brackets out and check, you're going to end up exactly here. So yes, you can use numbers that don't look like squared numbers and apply the dots principle. Okay, let's look at this one here. It doesn't look like it's a dots question because there's brackets this time. We've got a perfect square over here and then we've got to take away a 9. That's a bit confusing. However, we should recognize that a perfect square is a squared expression. It's actually n plus 2 all squared. We've got that subtraction in the middle and we've got the number 9, which is a squared number. So yes, it does follow the dots pattern, even though it looks a little bit more complex. So once again, to follow that pattern, we take the square root of the first term, square root of the second term, separate them with a subtraction sign. So the square root of the first term, this first term is all of what's in brackets, n plus 2. So we're going to put that into two sets of empty brackets. Remember, when we expand out dots, we get something with a plus and something with a minus. Okay, so this one here, square root of that just simply takes that squared away. So we get n plus 2 in here, n plus 2 in here. And then the square root of 9 is 3. So that's going to go into the sets of empty brackets. And we're simply going to separate those now with a plus and a minus. Now, if you look here, I've got some like terms that I can collect. So why don't we collect those? 2 plus 3 makes 5. 2 take away 3 makes minus 1. You'll notice now that I've expanded this out, it doesn't quite look like dots anymore. And that's simply because we collected those like terms. So to put this, if you were to expand this out, it wouldn't quite look like this, would it? It would be simply m squared plus 5m take away an m, and then minus 5 on the end. However, if you expanded that out first and then subtracted 9, it would get you to the same place. So that would be a good thing to do to check your work, to make sure that you've factorized this properly. It is a bit more advanced, it is a bit more technical, and it's using those skills and patterns of recognition. Okay, work example 3. We've got that perfect square again, except this time instead of them being added, they're being subtracted, and we're taking 7 away at the end. So we're now combining what we did last time with our first example as well. We've got 2 examples combined. So we've got a surd here, and we've got a perfect square here. This is quite tricky for people to recognize these. So once again, that square root of that first term is going to go into 2 sets of empty brackets. Square root of that is simply j take away 6. Square root of this one is a surd. It's going to be root 7. And then we're going to have a plus here and a minus here to fully factorize that. Now, because you've got -6 and a surd, root 7, technically speaking on your calculator, you could add the 2 together and subtract the 2 together. You're going to get something pretty nasty. Just leave it in surd form. Your teacher's not expecting you to evaluate this on the calculator, so don't even go there. Just leave it exactly as you see it there. And once again, you could expand this out, expand that out to check your work. And if there's a match, you know you've done it correctly. And our final example today looks a little bit more complicated again. This time I've got, it's not squared, it's to the power of 4, and I've got myself a fraction here. You might be thinking, my goodness, what am I going to do now? Well, once again, this is where your index laws are really handy, because you would recognize that k to the power of 4 is actually k squared, in brackets, squared. So once again, we got ourselves a squared number. And with your index laws, you would also know that the number 4/9 is the same as 2 squared over 3 squared. 2 squared numbers on the fraction. So index laws and surds, helpful for this video. Okay, so now we know we've got a squared number at the beginning, squared number at the end, even if it is a fraction, subtraction in the middle, it's dots. So first of all, we're going to take that square root from here and put it in both sets of brackets. This is our square rooted number here. We're just going to get rid of the squares, and it'll be simply 2/3 plus and a minus. We've factorized and we're done. This would be a little bit harder to expand out, I would imagine, because you're working with fractions. That would be quite nasty. I wouldn't even worry about that one, as long as if you're fairly proficient with all the other ones, you're on the right track. Okay, well, did you find this helpful? I sure hope so. It was a little bit more complex than what you're used to. I would say get yourself some practice, ask your teacher for some more practice questions. You could even write to me here at the channel and ask for extra practice questions. If you found the video helpful, here's some ways that you can engage further with us. First of all, like and subscribe, hit that notification bell so you'll always know when the next video is available to view. You can follow us on Facebook and Instagram. You could tell us in the comments or tell someone in one of your friends or your teacher about this video. Even consider giving back to the channel with super like. If you've got any questions at all, or like I mentioned, you want some extra practice with some nasty questions like this, I've got access to lots of textbooks. I can give you a hand. mcclutchymass@yahoo.com is the place to reach me, or if you've got any other questions about how to do things with regards to difference of 2 squares. Well, thank you so much for watching. I'm Natalie McClutchy. Have a wonderful day.